Okay, so let's start. So we're going to start with a power of 2. Okay, and we know from Pascal's triangle that this is the second row, so we know what our coefficients are going to be, but I'm just going to write this for us. So here's what I recommend using 3 different colors, okay, and I'm going to expand. So this is the key word, expand each binomial. So this becomes 2c. The first position in our row is position 0, okay? I'm going to put A, 2, C. The next position is position 1, okay? And then the third position is position 2, okay? All right, what we want to do now is we're going to use our first term, okay? And that is x. So we start x with the highest power we can, and that is the power that the binomial is raised to, and it's 2. Okay? This is x to the, we lose 1 power, so 2 to the 1, and then x has to be attached to this term too, and it's 0. Okay? And then last but not least, I'll do this here, we're going to use y. Okay? And it's a positive y, so I'm using both of these, but I'm just going to write y. Okay. If I start with 2 here, I have to have 0 here, and like I said, you can match these up. These are both the same, okay? Alright, so this is y to the 1, because I go from 0 to 1 to the power of 2. And just as a quick check that I did this, 2 plus 0 is 2, check. 1 plus 1 is 2, check. 0 plus 2 is 2, and that's correct. These are all separated by plus signs, okay? We know that 2c0 is 1 times x squared. What is y to the 0? It's 1, okay? 2c1 is 2. Sorry, bless me. Okay, x to the 1 is x, y to the 1 is y, plus 2c2 is 1, x to the 0 is 1 times y squared. Now, you're probably thinking, oh my word, I could have FOILed that in much less time if I had just FOILed. That's true, but it's always nice to start with something you know how to FOIL. So you know that you're doing it right. Alright, let's do another. We're going to do 1 to the power of 3. Okay, so what we're going to do is we are going to start with our Pascal's numbers. Okay, that means that we're in the third row. There are 4 positions in the third row, so we're going to have 3 or 4 C's. So we start with 3C0, 3C1, because that's the first position, 3C2, 3. If it helps to think about it, you could also say, hey, I'm listing every number in that row of 3s. So 1, 3, 3, 1 is the row. So this represents every single number in the row. Okay, so now we're going to start with our first term. That would be 2a. Okay, and I'm going to just go ahead and write all my 2a's here, and then we'll attach exponents in just a second. Okay, alright. So our first term starts with our exponent on our binomial, which is 3, and then it descends until it reaches 0. So we start at 3, then 2, then 1, then 0. Okay, alright, and now we have our second term, which is positive 4b, so I'm going to go ahead and write 4b here on all of these. Okay, and this is our ascending values, so we always start with 0 here, so 3 plus 0 has to be 3, so we started with 0, 1, 2, 3. And I know this sounds ridiculous, but if I were you, I would go back and make sure that this plus this is 3, this plus this is 3, and so on for all the exponents. This is one of the more common mistakes people make when we get into more complex problems, is they don't end up with the right exponents. So, yeah, so go do that. I'm also going to require, when you do work for quizzes and tests, I'm going to mark you off if you don't have plus signs between these. Most mathematical errors happen as a result of sloppiness, so if you want to put plus signs early on, go for it. But I need to see that you know that you're adding these together. Okay, so here we go. I'm going to just start by writing all of Pascal's numbers. Okay, so this is 1, 3, 3, 1. Okay, 2a to the third, that means 2 cubed, and a cubed, which is 8a cubed. 4b to the power of 0 is 1. So what's nice always about the first and the last term is always a times 1. Okay? Alright, 2a quantity squared is 2 squared, which is 4, and a squared, which is a squared, times 4b quantity to the power of 1, which is 4b. Okay? Alright, times 2a to the power of 1 times 4b quantity squared, so 4 squared is 16b squared, okay? And then 2a to the power of 0 is 1 times 4 cubed is 64 times b cubed, okay? So remember how I said exponents are everywhere in math? Do you believe me now? They're everywhere, so you really do need to know those properties. And these are all being added, of course, okay? Alright, so our final answer for our expansion is 8a cubed plus 48a squared b plus, what is that, 48? 96a b squared plus 64b cubed. So what you can notice about your answers, your a goes from a power of 3 to 2 to 1 to none. And your b starts with none to 1 to 2 to 3. It's a quick way to make sure you did that right. So here's your expansion. This is actually, it may not seem like it as you're learning how to do this, but it's way faster than FOILing. Okay, alright, we're going to skip that one and we'll jump to this one. Okay, so we're doing 5 rows. Okay, so I'm going to have to write extra small here. So I'm going to start by labeling my C's. So 5C0. 5C2, I have enough for 5C3, 5C4, oops, I don't think I'm going to, and then 5C5. It's just a little smaller and I'll move them or something. Okay, so, what we need to do is we're going to identify our first term, which has a value of positive 3. So let's go ahead and, oops, I'm going to do this in blue so y'all can see what I'm doing here. Okay, so I'm going to go ahead and say 3 for each of these. I'm still going to run out of room, but I'll do my best to write smaller. Okay, and these are always descending, so we start with our highest exponent, which is 5, and we lose 1 each time, kind of like a factorial does, okay? Except instead of stopping at 1, we go all the way to 0 here, okay? And then our second term is not just 2c, it's negative 2c, okay? I know it's kind of ridiculous writing in different colors, but on things that are complex like this, it helps a lot to be able to see exactly what you're doing on each step. Okay, so this is 0. We start at 0 and we ascend all the way until we reach our exponent of 5. Okay, and let's go through and put our plus signs in so we remember that we're adding. Okay. So I'm going to go ahead and do our Pascal numbers. Okay, so we end up with 1, 5. I always do these ones first because I know they follow the pattern. Okay, and then 10 and 10. Calculate those really quick so I didn't remember what they were. Okay, so 3 to the 5th is 1 times 3 is 243. And then negative 2c quantity to the 0 is 1. Okay, 3 to the 4th is 81 times negative 2c. Okay, times 27 times, now this is positive, so what you're going to notice is an oscillation between negative to positive, negative to positive, negative, okay? It's positive 4c squared. Okay, this is 3 squared is 9 times negative 8c cubed. And then this one is positive because it's to the 4th, so this is 16c to the 4th. Okay, and then 3 to the 0 is 1 times negative 32c to the 5th. Okay, so let's go ahead and put plus signs in. Okay. Alright, so we end up with 243. Oh, what is this? Minus 810c. Plus, I think that's correct. I should have pre-calculated this, I suppose. 108, yeah. Okay, times 10, minus 720c cubed. That was a plus sign in case you couldn't tell. Plus, 240c to the 4th. And minus, I can barely read my writing because I squished it together, 32c to the 5th. So this is this expansion. Now you have to admit this is way faster than trying to FOIL to the 5th degree. Okay, and that is what the binomial theorem is. So now you are free for the rest of the period to work on your homework, all right, which is posted as usual on Haiku.